Today's lesson is being recorded after school with no students in the classroom because I did not turn on the recorder while I was teaching, which means that this video will not have long pauses in it. If there's a place where there ought to be a pause, then go ahead and pause the playback. For example, if I give you an example to do, I'm just going to go ahead. I'll tell you to pause, and then when you're ready, when you've done it yourself, then you turn it on. So today we're doing solving inequalities, section 1.5. This is a review of things that you should have done in Algebra 1. So by inequalities, we mean greater thans, greater than or equal to's, less thans, less than or equal to's. You know, those should be familiar symbols to you, right? The first line is the greater than or equal to. You know, what makes it or equal to is the bar underneath the arrowhead, let's say. Less than or equal to. When you graph an inequality, you graph the endpoint, and then you add shading. So the endpoints are either open or closed, depending on whether it's an or equal to or not. For example, if I use x greater than or equal to 4, is 4 part of the solution? Meaning, is 4 greater than or equal to 4? Yeah, it's equal to. So I color in the circle over 4. But for x greater than 4, because 4 is not greater than 4, the 4 is not part of the solution, and I use a little open circle. Right? The shading is really x. So the shading, if x is greater than 4, then the shading is greater than, on the number line, that means to the right of 4. So the shading, here's the 4, and the shading is to the right of it. And anything to the left on the number line is less. So 4 is less than x is greater than 4, same thing. Okay, we use properties of inequality to solve inequalities, just like we use properties of equality to solve equations. And they could be summarized, the properties of inequality, as pretty much the same properties as they were with solving equations. Whatever you do to one side, you got to do to the other. Add, subtract, multiply, divide, square, square root, flip, etc. There could be more. But whatever you do to one side, you got to do to the other. And while you're doing it, it'll work the same, except for when you multiply or divide by negative numbers. Okay, when you do that, you've got to flip the inequality sign. Right? And the reason why is, if you notice the order of the numbers on a number line, right? When the numbers are positive, when you're to the right of 0, then 2 is less than 3. But when the numbers are negative, right, then the numbers are getting larger in a negative sense as you go away from 0. And actually, the negative 2 is greater than negative 3. That's why if I multiply by negative 1, it's going to flip the direction of the inequality symbol. So solve and graph. This is a typical problem for solving inequalities. Right? We solve it like we solved equations, meaning do operations to isolate the variable on one side. Your answer will be on the other, including the inequality symbol. In this problem, we need to do some simplifying on the left, so we will distribute. Negative 6x plus 15 plus 1 is greater than or equal to 4. Combine like terms. Negative 6x plus 16 is greater than or equal to 4. Subtract 16. Negative 6x is greater than or equal to negative 12. And now we're going to divide by 6. But again, when I multiply or divide by a negative, I'm going to have to flip that inequality sign. So I'm not even going to show it on the same line as this. I'm going to make one more line, negative 6x divided by negative 6, and flip the inequality symbol, right? Now it's a less than or equal to negative 12 over negative 6. And the negative 6's cancel. Negative 6 over negative 12 over negative 6 is 2. So we have x is less than or equal to 2. Right? And the graph of that would look like a 2 in the middle. That's the endpoint. It's closed circle because that's or equal to. And it's shaded to the left because if x is less than, the shading is less than or to the left of 2. Okay, you go ahead and try this, and if you pause the playback, then I'm going to go ahead and solve this so you can see what I did when you're done. So go ahead and pause now. Okay, I'm going to solve this now. Distribute negative 2x minus 18 plus 5 is greater than or equal to 3. Combine like terms, negative 2x minus 13 is greater than or equal to 3. Add 13. Negative 2x is greater than or equal to 16. Divide by negative 2. Again, I'm going to do this on another line, because here's where I flip the symbol. And let me go up here. Negative 2 over negative 2 cancels. X is less than or equal to negative 8. So there's my negative 8. Since it's or equal to, I color in the dot. I color in the circle above the negative 8. And it's less than or equal to, so it's shaded to the left. Word problem time. And if you see a word problem in the lesson, that probably means there's going to be one like it in the homework. A digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? And what I didn't say in class, because we didn't have much time today, is that this really does kind of fit the problem-solving template that we get from Hampton City Schools, right? The first is we got to read and understand the problem, right? And in this case, a good thing that we're doing there is probably to define our variable. What are we trying to solve for here? And what is the thing that we don't know? How many songs? So maybe as part of the first step of understanding what we're being asked, I'm going to define my variable. I'll say S is the number of songs for download. Okay, let's see, we have 2 plans, and we're trying to figure out how we could make one cheaper than the other. I think this is the part where we need to, I could call it part of the first step of problem solving, but it kind of bleeds into the second too. Let's write an expression that represents how much it costs by the first plan. Right? Plan 1 costs $9 membership fee plus $1 per download. So if I was going to write an expression to represent that, that's 9 plus 1s. Plan 2 costs $25, and it's 50 cents or $0.5 per download. So we'll say 25 plus 0.5s. Excuse me. Now, definitely in the part 2 of our problem-solving template, we would say, okay, we want to model the problem that we've got with math. And since we want to know how many songs do we download for the second plan to cost less than the first, then let's write the second plan, 25 plus 0.5s, less than 9 plus s. Okay, definitely now I have gone from the first step of problem solving, which is to read the problem and understand what I'm trying to do, to modeling, the second step, our problem with mathematics. The third step of problem solving is to solve the math problem, which is in front of us. So we're solving this inequality. Which is the smaller of the variable terms? 0.5s and 1s? Well, the smaller would be 0.5s. So we subtract 0.5s from both sides. Now we have 25 is less than 9 plus, and what is 1s minus 0.5s? And the answer is 0.5s, right? It's like 1 minus 1/2 is 1/2. Okay, now we subtract 9 from both sides. 16 is less than 0.5s. Okay, we still haven't solved it. We have to either divide by 0.5 or you could multiply by 2. In either case, 16 divided by 0.5 is 32. All right. So you could call it 32 is less than s, or s is greater than 32. Same thing. So that's what we solved in the third step of problem solving. We solved our math problem. Last step is relate it back to the problem you were given in the first place. What does that tell us? That tells us that if we rent or we download more than 32 songs, our second plan will be better. It'll be worth it to us to have paid a $25 membership fee. Okay, so that's the answer. Download more than 32 and then use the second plan. Okay, again, here's one I had you try in class. So if you want to do that, pause the recording right now, and when you're ready, push play again, and you'll see what I'm about to do. Okay. So let's solve this inequality, distribute. Negative 6x minus 2 is greater than negative 6x plus 7. Okay, I got to deal with the variable terms. I add 6x to both sides. I get negative 2 is greater than 7. Okay, well, let's see. Two things you notice about that. Number one, there's no variable, which means our answer does not depend on x. Number two, that's a false statement. And that doesn't depend on what the value of x is. That tells us that this inequality right here is never true. There is no solution. Okay. If you solve this, you didn't add 6x as your first step, because in class some students added 2 to both sides. So they ended up with something that looked more like 0 is greater than 9. It's still not true, so it doesn't really change our answer. So whether you got negative 2 greater than 7 or 0 greater than 9, it's still false, which means this is never true. There's no solution. Now, this one I did not have you do in class. I just showed. Now, if you want to try it on your own, again, pause now, and then I'm going to go ahead and solve this. When you're ready, hit play. Okay, distribute 10x minus 15 minus 7x is less than or equal to 3x plus 8. Combine like terms, 3x minus 15 is less than or equal to 3x plus 8. Subtract 3x. Negative 15 is less than or equal to 8. So in this case, again, there's no variable, so our answer does not depend on x. This statement, negative 15 is less than or equal to 8, is true. So that tells us that this inequality that we started with is always true. It does not depend on x. Another way you could say the solution is all real numbers. All real. Now, in your homework, there's going to be some questions that ask you to say whether these things are always true, never true, or sometimes true. This is the example of an always true, right? You get a statement which is true, and there's no variable involved, right? The one before, this is the example of when it's never true. You get a statement which is false, and there's no variable involved, right? If we go 2 back from there, this was the example, this is an example of a sometimes true, right? Because it is sometimes true. It's true for x values of negative 8 and less. It's not always true because it's not true for x's greater than negative 8. Okay, compound inequalities. Compound inequalities are 2 inequalities tied together with the word and or the word or. And this is similar to geometry days where you did some logic. And in logic, when you have 2 statements tied together with an and, then both have to be true for the entire statement to be true. So for a compound and inequality to be true, both parts have to be true. So x is greater than negative 1 has to be true, and x is less than 3 has to be true. Both must be true. Both must be true. Okay, if I graph this, let's graph them to see what that looks like. If x is greater than negative 1, that's an open circle on negative 1 and shaded to the right. X greater than, to the right on the number line. If x is less than 3, that's an open circle on 3 and shaded. X less than means to the left. Okay, the compound inequality is true when both of those are true. And both of those are true where the graphs overlap. So where do they overlap? They overlap in between negative 1 and 3. Right? Somehow, if you graph these, if on a test you graph, you've got both of them on the number line, you have to do something to make it clear to me that you understand it's where they overlap, which is the solution. You know, it's also possible to do this. You could write negative 1 is less than x is less than 3. We're going to see more of that next class. But that's called 3-part inequality. It tells you the values of x are in between negative 1 on the left and 3 on the right. You know, a 3-part inequality is an implied and statement. It's implied that x, negative 1 is less than x, and that x is less than 3. Right? That's just implied. You don't have to write the word and. It's understood. Right? If you write it like x is greater than negative 1, x is less than 3, not in a 3-part inequality, you have to use the word and. Okay, now we look at the or statement. And again, just like in logic, for an or statement to be true, just one part needs to be true. I mean, even think of our greater than or equal to, less than or equal to, right? It doesn't have to be, both have to be true. I mean, we're not going to have anything that's both equal to a number and less than a number, or equal to a number and greater than a number. If I say this is today is Tuesday, or it's dry, that's a true compound statement because one part is true. It is Tuesday. If I said today is Tuesday and it's dry, that's false because an and statement would require both parts of that to be true. So let's graph x less than -1, open circle on -1, less than means to the left, boom. X greater than 3, open circle on 3, greater than means to the right on the number line, and that is the graph. There's not much you can do. You're not looking for overlap. The solution is all of these values of x, right, and all of these values of x, and not the ones in between, and not -1 and not -3. So solve and graph. This is an and, so I know I need both parts to be true. Add 1, add 1. 6 is less than 3x. Divide 3, divide 3. 2 is less than x, which means that x is greater than 2. Divide 2, divide 2. X is less than 6. Okay, let's graph both of those. X greater than 2 means open circle on 2, shaded to the right. X is less than 6. Open circle on 6, shade to the left. And because this is an and, we're looking for where do those two graphs overlap. And again, they overlap in between 2 and 6. So I'm going to make that, I'm going to color all that in a way that makes it clear that I understand that's the solution. Right? It does not include that piece of the arrow. It does not include that. It's just these points here. And again, as a three-part inequality, I could write that like this. 2 is less than x is less than 6. That's an implied and statement. If instead I write it like this, as two separate inequalities, I've got to use the word and. Okay, finally, solve and graph. Here is our compound or. So we know we just need one part to be true for the whole thing to be true. Subtract 1, subtract 1. 15 is less than 5x. Divide 5, divide 5. 3 is less than x, or we could say x is greater than 3. Subtract 9, subtract 9. 3x is less than -3. Divide 3, divide 3. X is less than -1. All right, now if I'm going to write the solution, here's my solution. It's both of those statements. And it's got the word or. It has to have the word or. Now I'm going to graph it. X is greater than 3. Open circle, shade to the right. X is less than -1. Open circle, shade to the left. That's the graph. Okay, those were our objectives. I think we accomplished them. This is the homework. And again, when I say odds at the end, that means these are odds and these are odds, all odds. You have all the answers in the back of the book. We're going to have a quiz next class over sections 1, 2, 1, 3, and 1, 4. It means not this homework, right? Not this homework, but the homeworks from 1, 2 was properties of real numbers. 1, 3 were expressions, evaluate and simplify. 1, 4 was solving equations.